Assalamu alaikum. I am Mubashir Serniabat Sudipto. I'm from ECE department and my major is CSE. In this video presentation, we will learn about queue and circular queue, which is array based. Here are some details of me and my video presentation partner. At first, I'm going to talk about queue. Queue is a useful data structure in programming. It is similar to the ticket queue outside a cinema hall, where the first person entering the queue is the first person who gets the ticket. Queue follows the first in, first out FIFO rule. The item that goes in first, the item that comes out first. In the above image, since 1 was kept in the queue before 2, it is the first to be removed from the queue as well. It follows the FIFO rule. In programming terms, putting items in the queue is called NQ and removing items from the queue is called DQ. As we are implementing queue using array, at first we have to know what actually array means. Array is a collection of elements of the same type placed in contiguous memory locations that can be individually referenced by using an index to a unique identifier. Basic operations of queue. A queue is an object that allows the following operations. NQ. Add an element to the end of the queue, DQ. Remove an element from the front of the queue, is empty. Check if the queue is empty. Make empty. Clears or empty the queue is full. Check if the queue is full. Front. Get the value of the front of the queue without removing it. Simulation of queue. Queue operations work as follows: two pointers front and rear. Front track the first element of the queue, rear track the last element of the queue. Initially set value of front and rear to -1. Now we are going to show NQ operation. Here, check if the queue is full. For the first element, set the value of front to 0, increase the rear index by 1, add the new element in the position pointed by rear. Now we are going to show about DQ operation. Check if the queue is empty, return the value pointed by front, increase the front index by 1. For the last element, we set the values of front and rear to -1. Now, here is two sample codes of NQ and DQ showing the function of queue. Now we are going to talk about time complexity of queue, which is array based. The time complexity of class constructor is order of 1. The time complexity of make empty is order of on. The time complexity of is full is order of 1. The time complexity of is empty is order of on. The time complexity of NQ is order of on. The time complexity of DQ is order of on. As there is no loop in any of the operations, so here the time complexity will be always constant. Now we are going to show the uses of queue. Queue basically used for CPU scheduling, disk scheduling. When the data is transferred asynchronously between two processes, the queue is used for synchronization. For example, I/O buffers, pipes, file I/O, etc. Handling of interrupts in real-time systems. Call center phone systems and use queues for to hold people calling them in order. Thank you.
My name is Joy Islam. I am from ECE department, majoring in CSC. Now, my topic is circular queue. When we see the word circular, we can imagine a round shape or a ring shape figure, and as we know, queue is a linear data structure. When we combine this together, we get a circular queue. Now, what our question is, what is a circular queue? A circular queue is a linear data structure in which the operations are performed based on FIFO, first in first out principle, and the last position is connected back to the first position to make it look like a circle. In circular queue, the rear end is connected to the front end. here is a picture which represent as the visual representation of a circular queue using array. Now, to implement the circular queue, we must follow some basic operations, or we must do some basic operations. Those operations are enqueue and dequeue, is empty or is full, make empty and front. Now, enqueue and dequeue are the functions which help us to add an object and remove an object from the circular queue. We add objects using enqueue and remove using dequeue. To make sure that the circular queue is empty or full, we use is empty and is full to check whether they are empty or full. Now, to make the queue empty, we use make empty function, and to get the front value, as we are using queue which shows or which shows us the front value, we use front function without removing it. Now, here is a visual representation or simulation of enqueue and dequeue in a circular function. When we enqueue a function, we have to keep a single array index empty. Now, when we enqueue a object inside a circular array, first the front and rear pointer is equal to 0. Now we have to keep adding the new objects to the rear of the front value, and as we are adding, the rear pointer will keep shifting. Now, if when the queue is full, the rear pointer will be equal to the front pointer, and when we are dequeuing an object from the queue, the dequeuing will be from the front, as it follows the first in first out rule. As we can see, the 14, 22, 13 minus 9, the queue is full. Now if we start dequeuing, we have to dequeue from the front, 14, then 22, then 13, and when we again want to enqueue object, we have to enqueue from the rear. Now here is a sample code. We are using try catch to avoid any kind of exceptions. Now here are the time complexity of for each functions. As we can see, all the time complexity for each function is order of 1. As we are using no loop in the code, here we can see there is no loop, so the time complexity will be order of 1. We are enqueuing and dequeuing one by one. Now the uses of circular queue is CPU scheduling, memory management, and traffic management. That's all. Thanks for watching.